Hello passengers, welcome to Tech Deep Dive with Rito. Hope you all are doing great. Our today's agenda is there are 4 points. Number one is the same thing which we have covered in the part 1, which is print each character and its recurring count. The string is so welcome. Number 2 is we are doing the same thing but using collectors. So earlier we have done it using getOrDefault method from the stream API. Now we are doing the collector from the stream API as well. So we are going to use Java 8 completely, just for your information. And these are the prerequisite which we have already discussed in our earlier video, part 1 video or part 2 video. You can check it out. Okay, and then number 3 is we are going to deep dive on some method interfaces in the Java stream API, which is collect, collector, and groupingBy. Number 4 is now we are going to calculate the real-time time complexity for both of them and compare with respect to that. So let's jump to our editor. As I said, using Visual Studio Code. So now we are just creating one file which is duplicate char.java. Okay, psvm, and then we are declaring greeting welcome. Okay, now what we want to do, we are using collector and groupingBy as well as counting. We are going to count and print each and every character of welcome. So now what do we want to do, we are just taking cats, which is returning the int string. Then we are going to dot mapToObj. Okay, so this is the method which is returning the map with respect to each and every object. So mapToObj. What is a mapper here? So we are going to use the lambda expression, then convert it, typecast this to character, and then we are collecting this, right? Let me put this in the next line. Dot collect. This is the collect, and what do we want to collect? We want to collect. Now we are using collectors dot, this is groupingBy. What we want to groupingBy? We basically groupingBy again. We are using the lambda expression, and then this is the particular character and it's counting. So how we are going to get the counting with respect to each and every character? We are going to using the collector again and do the counting. Now we are getting this counting, and that is returning a map, right? So now it will be very useful for us to traversing the map using the lambda expression. Okay, so for each and every key and value pair, what we are going to do, we are simply printing using the lambda expression. Okay, now we are going to print this k and v, which is key and value for this. So now let's say for example k plus, this is v, right? We can give some arrow over here for our better understanding. Let me check. So there is no error. Now it's fine. Okay, so what we did actually, we declare a string which is welcome, and we have converted this string to the cats, which is giving the int stream. So this is a kind of converting the stream, and we're going to convert this particular stream to map to object. And map to object, what it did basically, so it returns an object value stream consisting of the result of applying the given function to the elements of the stream, right? So it is returning a object value stream here. So with respect to each one character, and we are typecasting that particular character, and then we are collecting. So what is this? This is basically the mutable reduction operation, okay, on the elements of this stream using collector, right? So this is performing mutable reduction operation, and this is also, implementation of the collectors. Okay, we are going to deep dive this later as well. So as of now, just trying to understand how it is collecting, and it is grouping by. What is grouping by? And it is returning the collector, and this collector completely, this is returning the map. So map which is containing the character and then long and then object, because it is getting the map to object. This map we are going to do the for each and every key and value pair. Hope you'll get the concept. Let's go to our agenda. So this is we have already done, but we have to execute this code. So let's execute this, and we are on the same location. Yeah, location is perfect. Let's have to execute this one. This is T. Great, but this is a kind of unordered execution. Okay, unordered means it is not maintaining the order, because earlier we have using link hash map, we are getting ordered set of output. Ordered means the way maintain order, we have given the input the same order, we got the output, but here we are not getting the output in order. Okay, so that's fine. So our purpose is to check the time complexity. So let's check this. Now we are going to number 4 agenda, counting the time count. So we are going to understand the time complexity for both the program, then we'll go a little bit deep dive with respect to different component. Okay, fine. Here take a long type data type, take start time system. We are going to get some time as millisecond. Now after completing this program, again we are going to take some end time, then we are going to declare as same thing dot current millisecond. Now we have to subtract to find out the time. We have to subtract. I'm just putting one new line so that we can understand output. We can put like this: the time difference is plus. We can do the plus like this way. First we have to put the end time, then subtract, then start time. Okay, so let's do the CLS and run this program. This is taking the time difference, you can see that 12 milliseconds. So let's go to another program. Delete this one. This is actually we have done earlier in our earlier video. I have already mentioned the 2 or 3 lines of code for calculating the execution time. Again I'm executing this. What is this? Duplicate cat. See, the time difference is 5, and for this the time difference is 12 milliseconds. So as per our practical implementation, this code is taking a little bit lesser time than this code. Let's go to deep dive this line. What is it? We'll go and check the Oracle documentation for those new terminology. Got this point? This is a string type variable which is greetings, and greetings dot. So now let's start with cat. This is under string dot class. So what is this basically? This is a method whose return type is int stream containing the int. Okay, and this is returning in stream object, and the internal logic is this is checking Unicode coding standards, 16-bit Unicode standard, and it is going to char splitterator. So what is this? This is a kind of method, right? String UTF-16. Let's deep dive into this. So here you can see this string UTF-16, then $sign char splitterators dot class. So let me tell you why this $sign is mentioned here. Whenever the $sign mentioned, that means this char splitterator dot class is inner class. Let me show you quickly. This is the method, and this method is coming from the class which implements splitterator dot of int, and this static class is belong to, or it is available under, let me go to top. This is the Oracle documentation, and this is the string UTF-16 class. So this is the parent class. So under this class, so this char splitterator dot class, so this is the inner class. That's why they have mentioned this. It is showing the $sign. Let me go to again to this character and this splitterator so that we can pointing the same location where we were. So now char splitterator, what it does, it is taking the byte type array and some integer. So basically it is returning. If you go to the declaration, you can see this is taking some byte type array and some integer. We are providing the value as well as splitterator dot immutable. So if you go to this splitterator, this is the interface. If a remaining element exists, perform the given action on it. So returning true, else return false. If this splitterator is ordered, the action is performed on the next element in encounter order. Fine. So let's go to string again. What is immutable? So immutable is there is some value, right? There is some value. So what is this? Characteristics value signifying that the element source cannot be structurally modified. Why it is not modified? Because it is final. Okay, that is element cannot be added, placed. So that is why it is called immutable, right? Okay. Now such changes cannot occur during traversal. A splitterator that does not report immutable or concurrent, it expect to have a document policy. Let's go to our original method where it start actually. So this is basically returning this int stream. So this int stream, it is converting this string to int type stream. Okay, now go to the, let me close this one, otherwise it will be confusing for you. Let me go to mapToObj. So what is it? So this is under in stream. Okay, so what is in stream? In stream is an interface which is extending base stream with a generic of integer and int stream. Let me go to again mapToObj method. So this is basically, and what is this? What is the mapToObj? So return an object valued stream. Okay, so it is returning a object valued stream consisting of the result of applying the given function, right, to the element to this stream. Okay, so now it is the param, the element type of the new stream, right? U is the element type of the new stream. And what is mapper? So mapper is stateless and function to apply each element. So what it does, it is returning a object valued stream consisting of the result of applying a given function to the element of this stream, right? Okay, so it is returning the object valued stream, right? So now how we are doing mapToObj? Okay, so we are converting it to a object valued stream. Now it is int function which is extend the mapper. Let's go and check a little bit what is mapper. So mapper is, as I said earlier also, it is a function to apply for each and every element. Okay, so each and every element means this is each and every character of this particular string, right? So this is a complete string, and this is a small character, each and every character. So it is applying that particular character, applying the mapper function. Okay, and then what is collect? Let's go to the collect. Collect is another method of stream. So let's go to some note. So what is it? Basically perform a mutable reduction operation on the element of the stream using collector. Mutable reduction operation. So that what does it mean? Mutable, that means it can be changed, it is changeable, right? A collector encapsulates the function used as argument to this, allowing to reuse of collection strategies and composition of collect operations such as multi-level grouping or partitioning. Okay, so what is it basically? This is returning the type. This is the type of result. And what is A? A is the intermediate accumulation type of the collector, right? So this is returning the type of result and intermediate accumulation type of the collector. Okay, so don't worry if you are not able to understand, just try to listen to this. Okay, so in a nutshell, returning the result of reduction. Okay, in the first point we have already mentioned that this is mutable reduction operation, so that will reduce something. So this is a kind of reduction operation. And so how it will reduce? It will go to collectors. So what is collector? This is a final class. This is a final class, and we'll go to the groupingBy method which is available in the collectors. This is basically returning the collectors. If you go to the groupingBy node, see, returns a collector implementing a cascaded groupingBy operation on input element of type T, right? So type T is the input element, right? And this is the map, right? So the collector generic is T, and this is the map, and it is returning the collector, okay, containing the map. Next is grouping element according to the classification function, and then performing a reduction operation on the value associated with a given key using specific downstream collector. Okay, so basically it is used for reduction operation. Okay, and it is returning kind of collector containing the map. Okay, if it is containing the map, then like here we are going to send each and every character and the collectors downstream. So it is taking this particular each and every characters. Okay, here that is a classifier, right? And the collectors downstream operation, and it is internally using hash map, right? So that's why it is not using the linked hash map, and it is using hash map. That's why it is unordered. Okay, so basically what it is returning, classifier and then hash map and then downstream. So downstream is basically this one, the counting we are passing, right? We are passing this one, these two parameters here. Okay, so now it is returning the map. So with respect to that particular map, we are going to do the for each to that particular hash map, right? And we are printing this particular result. Okay, so that's it for this video, guys. Hope you'll understand the concept, though it will little bit in depth because showing the Oracle documentation, and it's kind of complex for the beginner level audience. I'll try to clarify each and every point more, okay, in some other video, some other time. As of now, I have to end this video. Okay, hope you enjoyed this video a lot and you have learned something new. If you like this video, please like, comment and subscribe this channel, and share this video with your friends and with your network so that other people can know this and get that benefit. Okay, it's time for bye now. Thank you so much for watching this video and hope it will help a lot. Thank you. Take care. God bless you.